For instance, if you look at the impedance matching for an antenna, we often see this kind of curve regarding the reflection coefficient gamma. And always the reference line of less than 10 dB is viewed as the impedance bandwidth of the system. So why is it like this? What does it mean? Let's take a transmission line system as an example to explain this. Let's assume that this system is connected to a load such as an antenna. If 100 watts of power is fed into the antenna, due to the imperfect matching at this reference plane, there will be reflected power. Let's say the reflected power is 10 watts. What's the corresponding value for the reflection coefficient? As the reflected power is proportional to the square of the magnitude of gamma, we can quickly guess that the magnitude of gamma is the square root of 1 over 10, which is approximately 1 over 3.16. However, more often, the reflection coefficient is expressed in decibels, so we can quickly get to an equivalent of minus 10 dB. And this kind of matching expressed by reflection coefficient in dB is commonly used in academia. Then, what's the case in industry? Often, it's expressed in standing wave ratio, abbreviated as SWR. And the relationship between SWR and the reflection coefficient is this equation. So the equivalent SWR is 1.9, which can be obtained by either a MATLAB program or a calculator. Also, we can make a quick calculation by assuming that the magnitude of gamma is 1 over 3 instead of 1 over 3.16, and we can get that the SWR is 2. So, in conclusion, a 10% of reflected power is equivalent of gamma being minus 10 dB, or SWR being 1.9. The former one is commonly used in academia, and the latter one is commonly used in industry. So here is a table of the commonly used gamma values in dB. For instance, minus 6, minus 10, minus 15, and minus 20 dB. And the corresponding SWR is 3, 1.9, 1.4, and 1.2. And the corresponding reflected power is around 25%, 10%, 3%, and 1%, which means that as the magnitude of gamma decreases, the reflected power also decreases. Or we can use another table by adopting the commonly used SWR values, which is 3, 2, 1.5, and 1.2. Then we can get the corresponding magnitude of gamma in dB in this row. We can notice that this row and this row are quite close, and the reflected power is also quite close. In conclusion, this row of gamma values in dB are commonly used in academia in expression of how good the matching is, whereas in industry, this row of SWR values are more commonly used.